Hello everyone, I'm Indumati, Teaching Associate in the Department of Computational and Intelligence, SRMIST, Katrangulattur. Today I'm going to discuss about one of the important clustering concept called K-means clustering. So before going to start with this topic, we should aware of what is clustering. So it's a natural analytical approach which will check whether two data points are having the similar features or not. That is, the formal definition here represented here as the natural analytic approach is to check if some points are grouped together in the data forming a neighborhood. So being able to detect such neighborhoods will help us find the objects that have similar features or not. So the problem of automatically detecting neighborhoods in the data is called as clustering problem. The basic objective of clustering is it will construct the cluster of points with low intra-cluster distance and higher intra-cluster distance. So the definition for intra-cluster distance refers to the pairwise distance of the points in the same cluster. That is, within the cluster, the distance should be minimum. With outside of the cluster, from one cluster to another cluster, it should be higher. So that is what mentioned as one of the main objective of clustering concept. So the cluster of points, when we are trying to construct a cluster of points with low intra-cluster distance as well as the higher intercluster distance. So intercluster distance refers to the distance between points in different clusters. So the clustering objective is to create a point of local cluster, and at the same time the clusters are separated as much as possible. It should be as far as far, right? So in a good clustering outcome, the data points in the same clusters are highly similar and the data points in the different clusters are highly dissimilar. So in order to find the similarity measure, we can adapt one of the important approach called K-means clustering algorithm. So this K-means clustering algorithm creates K representation of K clusters. So based on the K value, we can form a group of data points. If I mentioned K is equal to 2, then for a given data points, we are supposed to create two clusters. So to create the representation, the algorithm computes the point that is in the very middle of the cluster, which is nothing but we are supposed to find the centroid of the given data point, right? So the middle point is nothing but average or mean. Since the algorithm deals with K cluster, it deals with K average of the K groups of points, and hence the name of the algorithm become K-means algorithm. So just consider this example. If you have a one-dimensional data set in which we have a group of points containing values like 5, 10, 6, 9, 10. So for this one-dimensional data point, you will be getting a one-dimensional centroid. So how do you compute the centroid value here? The centroid of the group will be the average of the points, which is nothing but just add all data points together and divided by the number of total points. Here we have 5 numbers. So 5 plus 10 plus 6 plus 9 plus 10 divided by 5, which will give you 8. So for this one-dimensional database, the centroid value would be 8 here. Similar way, if you have considered a two-dimensional data, what if you have two features, feature 1, feature 2 with the values like 4, 6, 9, 11, 6 and 5, 10, 10, 14, 7, then for each and every feature, just adapt the same approach to find the center point. You will be getting two-dimensional centroid, which is nothing but 7.2, 9.2 in this case. So please notice that the centroid of a group of one-dimensional point will always provide you one-dimensional centroid value. The centroid of a group of two-dimensional points will be two-dimensional, right? If you have multiple dimensionals or multiple features, accordingly it will be increased. Now, I just wanted to discuss with this K-means clustering algorithm with one numerical example. So in this, we have two features, that is two-dimensional data sets x1 and x2. total number of data points, n would be 1, 2, 3, 4, 5, 6 here, and the k was represented as 2. That is, for this data set or data point, we are supposed to form a 2 clusters. And in the question itself, they have given the centroid, initial centroid value. That is, randomly they have selected some centroid value to compute to proceed with the next procedures. So the initial centroid value for these two-dimensional data here is, first one is 2, 1, and the second centroid would be 2, 3. So based on this, if you have plotted the data points, then you will be getting this kind of a graphical representation. Right? Now, the next immediate step would be find the distance between each and every cluster available in the question, the centroid point available in the question with each and every data point. Here, the 1, that is x1 is 1 and x2 is 1, which is nothing but altogether we can consider as a single data point or a vector. So here x1 is 1, 1, x2 is 2, 1, x3 is 2, 3, x4 is 3, 2, x5 is 4, 3, and x6 is 5, 5. This is what my data point. Now, it's time to find the distance between each and every data point with respect to available centroids. So, the first centroid value would be 2, 1. Right, which is already available in the question itself. So you can find the distance using the Euclidean distance calculation formula. Then you will be getting the final distance value. The formula for Euclidean distance is square root of x2 minus x1 the whole squared, y2 minus y1 the whole squared. So simply substitute this 1 as x1 and this 2 as x2 and this particular 1 as y1 and this particular 1 as y2. Then simply substitute the x1, y1, x2, y2 values in the formula. You will be getting the distance. So in that fashion, we received these distance value with respect to each and every data points. And moving on to the second class centroid value, which is nothing but 2, 3, use the same approach, but here the one and only changes x2, y2 value, which is nothing but 2, 3. Simply substitute the x1, x2, y2 as 2, 3 instead of 2, 1. You will be getting the another distance. Now compare, you have two distance, right? So now compare these two value. Which one has the minimum distance value? That is 1, right? So according to the clustering objective, intra-cluster distance should be minimum. So that is why we are considering the minimum distance. So I'm just taking the minimum distance out of these two distance values, which is 1, 0, 0, 0, 2, 3.61. This is what my minimum distance. So based on that, we can assign the center value. Since 1 is the minimum distance, so for this particular data point falls under the first cluster, that is V1. That is why it is represented as V1. And here also the minimum value falls under the V1 category. So the assigned cluster would be V1. But in the third data point, we have a minimum distance in the second cluster point, that is 2, 3. So that is why it is V2. And in the fourth data point, both are same values. So you can randomly select any one of the distance or centroid. So I have selected V1 here, and for 4, 3 it is 2.82 and 2, the minimum distance value is 2, 3. So it would be V2. And here again it belongs to V2. Now we have segregated or formed different two types of clusters, right? So once for one particular cluster falls under V1 category and another cluster group is V2 category. So that is what mentioned here. For V1, x1, x2, x4 points are there. For V2, x3, x5, x6 points are there. So in total, for cluster 1 we have 3 data points. Similarly, for cluster 2 also we have 3 data points. And for the next iteration, we are supposed to compute the updated center value. How do you do that? you just take this particular formula for new updated centroid calculation V1, which is equal to 1 divided by C1 is nothing but total number of points available in the cluster 1, and then simply take the x1, x2, x4 points, and you will be getting 2.00, 1.33. So C1 is 3, right? So total number of data points available in this particular cluster 1 is 3, and then substitute the x1 value, which is 1, 1, x2 value is 2, 1, x4 value is 3, 2, and add all together and then multiply with 1 by 3, you will be getting 2.0, 1.33. This is what the new updated centroid value. First centroid value. Just adapt the same approach for finding the next centroid value. You will be getting 3.67 and 3.67. Now, with the help of the updated cluster value, do the same approach for the second iteration also. So consider the V1 as 2.00, 1.33, and next centroid as 3.67 and 3.67. You will be getting the distance value, and based on the minimum distance, assign the new cluster. Now the data are divided into two clusters. For the first cluster, 4 data points are available, and in the second cluster, only 2 data points are there. Now again recalculate the centroid value based on the same formula. You'll be getting 2.00, 1.75, 4.5 and 4. In the third iteration, use those centroid updated value to find the distance calculation. If you observe carefully, in the third iteration itself, nothing, there is no change in the assignments, right? See, data point 1, 2, 3, 4. First 4 data points are belongs to cluster 1 only. The last 2 data points are belongs to cluster 2 only. This particular formation we already achieved in the second iteration itself. If in this case, that is, since no points are reassigned to different cluster, we observe the centers we don't need to recalculate the center again. It's a convergence. That is, we can say that we have reached the convergence phase, right? So the final cluster assignments are for cluster 1, x1, x2, x3, x4, and for cluster 2, x4, x5 with this updated centroid value. This is how we can solve the k-means clustering. Thank you.